Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have started discussions about the chapter sound, and we have seen some of the topics related to sound. What is sound? What form of energy it is? What effect or what impact does it have on us? These various things we have already discussed. Today, we will be discussing a separate topic is about wave. It's actually related to sound because we have discussed in the previous class that sound is a form of wave. You know that when sound travels, I have said that when sound travels, basically sound is a disturbance that is being created in a certain point in the space, and that disturbance travels from one place to another place. The region where it is originated is the source of the sound, and the place or the point at which it is moving and being listened by some person, that point is called the sink. Okay, so the sound is being moving from the source to the listener or source to the sink. So how does this sound moves? We have discussed that the sound moves through the vibration of the particles of the medium, and you must understand this thing that while the sound is traveling, the medium particles do not get displaced from their original position. They just simply vibrate about the mean position and transfer the additional amount of energy that is being generated by the disturbance, that is the sound, the source of sound. Okay, so basically this kind of propagation of the disturbance can be regarded as the wave. Wave is nothing. What is wave? Wave is nothing. Wave is but the propagation of a disturbance. It is the wave. Okay, so wave can be actually of two types. So if I consider wave can be actually of two types. What are the two types? One is the mechanical waves, okay, and another one is the electromagnetic waves. What are these two different kinds? Electromagnetic waves. Okay, so first let us just have a brief details about these two types of waves: mechanical wave and electromagnetic wave. Okay, so what is mechanical wave? See, the sound wave, they are processed by the phenomenon by which sound is traveling from one place to another. That kind of wave is called the mechanical wave. Why mechanical wave? Because see, the mechanical wave actually requires the vibration of the particles. The particles actually need to vibrate or move. Okay, here the energy is transferred in the form of mechanical energy, vibrational kinetic energy, isn't it? So this kind of wave in which the disturbance or the energy is traveling in the form of kinetic energy, vibrational kinetic energy, can be regarded as mechanical wave. And as in the case of mechanical wave, as we have seen that this mechanical waves always requires a medium. Okay, so mechanical waves always requires a medium. So if sound wave is a mechanical wave, then definitely it requires some medium. Other than the presence of a medium, a sound cannot travel from one place to another place. So these are the mechanical waves. Now on the other hand, there are some other kinds of waves or disturbance that can be generated. You have not studied this concept till now, but you will be slowly studying this in some part in class 9 and in some part in class 10, and the remaining concepts will be taught in the higher classes. Okay, so actually electromagnetic wave is formed by the combination of the electric and magnetic fields. Okay, now you must be wondering what are electric and magnetic fields. It is nothing. You know that a magnet have an influence or certain impact on other magnetic materials or other magnets in a certain region around it. Okay, this impact is called the magnetic field. Okay, this region where the magnet shows its impact is called the magnetic field. And what about electric field? You know that there are two kinds of charges: positive charge and negative charge. Okay, and these charge can be generated when you say run a dry comb through your dry hair, which is shampooed very well. Okay, clean hair. Okay, and if you just comb your hair, that comb acquires certain kind of charges, and if you have done this experiment, you will be knowing that this comb, after you brushed your hairs, okay, can attract small pieces of papers. Okay, another example where you can see these charges existing is actually when in winter season, when you keep the blankets one over another or keep the sweaters one over another, sometimes you hear some chirping noise. Okay, and you can also sometimes see, if you see in dark, you can see some sparks. Okay, so those are due to the accumulation of charges, due to the presence of excess charges. So these charges can also, like magnet, create a field around itself, and this field is known as electric field. Okay, so basically electromagnetic wave is generated by the combination or by the interaction of the electric and magnetic field, and generally this kind of wave do not require medium, does not require any medium. They can travel through any medium, but it is not mandatory that without or in the absence of any medium they cannot travel. It is not like that. In the absence of medium also these waves can easily travel. So these are electromagnetic waves. Now sound is basically one kind of mechanical wave. Okay, so it requires always a medium to pass through. Now again, if we just see the further classifications, this mechanical wave can be of two types: transverse mechanical wave and longitudinal mechanical wave. So if you just see the types of the mechanical waves, there are two types again. So I am making the heading mechanical waves. Mechanical waves are again of two kind. Okay, first is the say consider longitudinal mechanical waves. Okay, so what are longitudinal mechanical waves? Longitudinal mechanical waves. Okay, see. In some propagation of waves, what happens when the wave is traveling in, say, in this direction, from the left side of the boat to the right side of the boat. The wave is traveling in this direction, that is the disturbance or the energy is traveling along this direction. And we see that the particles of the medium are vibrating to and fro in a direction either parallel to the direction of the propagation of the wave or in a direction opposite to the direction of the wave. Okay, so actually the medium particles are vibrating parallel to the direction of the propagation of wave or just 180 degree opposite to the direction of the propagation wave. So the wave is being propagating in this direction from left to right, and the medium particles, if we just see the pen movement of this pen, the medium particles are vibrating like this, left right left right left right, like this. Okay, so it's to and fro motion, and the wave is moving from the left side to right side. Okay, so basically the medium particles vibrate in a direction either parallel or anti-parallel to the direction of the propagation of wave. This kind of wave is known as longitudinal wave. So this kind of wave is referred to as the longitudinal wave. Okay, so if you want to write down the definition, please note it down. So what are longitudinal waves? What can we say? Longitudinal waves are those waves in which the medium particles vibrate in a direction parallel to the direction of the motion of the wave. Okay, or rather you can also say it, longitudinal waves are those waves in which the medium particles are vibrating in the same direction in which the wave is traveling. Also you can say that the medium particles in longitudinal waves are vibrating to and fro in the direction of the direction of the propagation of the wave. So these are the longitudinal waves. So I hope the concept of longitudinal wave is clear to all of you. And the second kind of mechanical wave that we have in hand is the transverse mechanical waves. Okay. So what is transverse mechanical wave? Sorry, transverse mechanical wave is a just different thing, just a opposite kind of thing. Say the wave is traveling in this direction from left to right of the board. What happens? The medium particles are actually vibrating up and down with respect to the direction of the propagation of the wave. Okay, so the medium particles are vibrating up and down. In longitudinal wave, what was happening? The medium particles are vibrating to and fro in the direction of the propagation of wave. However, in case of transverse wave, the medium particles are vibrating up and down, and if you consider the direction of the vibration of the particles is perpendicular to the direction of the propagation of wave. So this kind of waves are called the transverse wave. Okay. So if I want to define transverse wave, how can I define it, or how can you just define the transverse wave? It can be defined in such a way. You can note it down. Transverse waves are those waves in which the medium particles vibrate in a direction perpendicular, that is up and down, okay, perpendicular to the direction of the propagation of wave. So transverse wave are those waves in which the medium particles vibrate in a direction perpendicular to the direction of the propagation of the wave. So these waves are called the transverse mechanical waves. Okay. With longitudinal waves, there are two terms associated. One is compression, and the other one is rarefaction. We will be discussing these two terms in the next class. Just note it down. And with transverse wave, there are two terms associated. One is called the crest, and one is called the trough, T-R-O-U-G-H, trough. Okay. So these are the terms that you must associate with longitudinal wave and transverse wave. Okay. So today we will not discussing these two terms, these four terms. In the next class, we will be discussing in details about the propagation of sound, how the sound waves travels, how compression and rarefactions are created, and in that context, we will also discuss the crest and trough. Okay. So this is all about the waves. Okay. So we will be ending our class here today. In the next class, we will be discussing the propagation of sound. Till then, please do study well. If you have any query, do mention it in the comment box. We will be happy to solve your problem. Thank you. Goodbye.